Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay back with yet another geometry video for you all, and our new lesson is all about extended problems with parallelograms. Now, I'm really fond of these new lessons that I've been creating after each and every single sequence of lessons that go along with each other and out of each and every unit, just to recap along the problems that we've already went across and trying to review all of the different basic items that we've also learned. So basically the fundamentals that we've learned in these units and these lessons that lead up to this given lesson, and also all of the problems that we've went across. This extended problems video is all about the complex problems upon these different lessons that we've been doing on parallelograms and quadrilaterals alike. But before we jump into today's lesson, please make sure to smash that subscribe button down below. Hit that like button on this video, as well as turning on your post notifications by clicking that little bell icon right next to the subscribe. Feel free to utilize the comment section down below and give us some constructive feedback or some general feedback on what you think of our videos so that we can try and implement your feedback in our videos to come. So as I was saying, we're going to focus on these complex problems of parallelograms. We're going to look at the different types of these complex problems regarding specific parallelograms, distinguish parallelograms and some specific types, as I will introduce another specific type of parallelogram, another specific classification of parallelograms in this video as well. And we're also going to look to solve them. So this is much more work-oriented rather than learning-oriented. You're going to be learning the process, of course, but it's more about doing. So I really suggest that before I get into each and every single separate problem in which I will indicate to you, please make sure to pause the video itself, try and look at what the problem says, what it actually gives you, use that information, try and think it up in your head, think up a storm in your head, how to actually solve it and what the answer might be. And then, of course, click play to see if your answer is correct. And, of course, follow along with my process. So without further ado, let's jump right into it. Let's start off by introducing that unique type of parallelogram. This rhombus is a very specific type of parallelogram, but it shares the most properties with a given parallelogram. Therefore, it's not distinguished by much other than one singular property. So this is rhombus's part one. I'll introduce my rhombus, and then, of course, I'll give you the types of problems, and then we'll go through each and every single one of the 4 different types of problems. So let's introduce what rhombuses are. So introducing rhombuses. A rhombus is a quadrilateral that has 4 equivalent sides and can be further classified as a parallelogram. So in terms, a rhombus is a parallelogram or a quadrilateral, but let's refer to it as a parallelogram. So it's a four-sided figure. That's a parallelogram. That has 4 equivalent sides. So that means that it has equal opposite angles because it's a parallelogram and equal opposite sides to the point in which all 4 sides are equivalent. And some things that you might think of is it's very similar to that of a kite, which is a different type of figure, which will go into depth. It's a very complex figure. But if you think about your general kite, like the one that you fly in the wind, oftentimes they might be shaped in the form of a rhombus, or they might be shaped in the form of an actual kite in geometry. Rhombuses have identical properties as that of parallelograms, but they have 4 congruent sides and different properties between diagonals. They have very similar properties between diagonals, but they're much more unique because you can actually calculate the given area of your rhombus with the given side lengths of a rhombus as well. And this, of course, is a picture of a rhombus. So it looks very similar to that of a parallelogram, except that it has 4 equivalent sides indicated by these little markings right here. All 4 of them have the same amount of tick marks, therefore they're all congruent. And then, of course, we have our central angles here splitting up our 360-degree angle here. So those are your right angles here all throughout the center. And then you have congruent opposite angles, of course. And one thing that a lot of people get confused on is in a rhombus, people oftentimes misconceptualize and think that, oh, all angles must be equivalent then. If a rhombus has 4 equal sides, it must have 4 equal angles. Well, that's when you're starting to mix into squares. That's the only property that distinguishes squares, and therefore a rhombus is not a square. So it must have opposite angles, but then again, there can be 4 congruent angles because then it would be a square. It wouldn't have that slant to it. Rhombuses part 2. Let's look at rhombus classification on a further frontal bird's eye view. So rhombuses are a special type of kite, which would be classified under a parallelogram, as we said in the first slide. And squares have congruent sides and are parallelograms, which makes them qualified as rhombuses. So as I had referred to in my first parallelograms video, Parallelograms part 1, I showed you the entire quadrilateral tree. So that included our trapezoids. These are all your regular shapes. So you have your trapezoids, its own classification, and then of course we had our parallelograms, which are broken down into your rectangles and your rhombuses, and then those are further broken down into your squares. So a rhombus does have a specific classification, and that can be a type of square. So a square is also a rhombus, as well as a rectangle, as well as a parallelogram, as well as a quadrilateral. So this is your given parallelogram here. And like I said before, if you have a square here, like I'm drawing out here, the only difference between your square and your parallelogram, so I'm right here, versus your square, sorry, not parallelogram, your rhombus. And rhombus. The only difference between them is that the angles are congruent. So it's going to have 4 congruent angles. It's going to be 4 congruent angles. And these are all going to be 90-degree angles. And these guys are going to have opposite congruent angles. All right, let's move on to the types of problems, what you guys are really here for. So practice with parallelograms, all the different types of problems we're going to be covering today, I'm going to include on the slide, and then we're going to jump right into them. So the first type of problem, we're going to use the diagonals to calculate the area and perimeter of a rhombus, as I showed you before. We're going to be given the values of our diagonals, and with those given values, we're going to have to come up with the area of the entire rhombus, as well as the perimeter. And then we're going to calculate the perimeter on a graph of a parallelogram in general. So we're going to put it on a graph, utilize the distance formula of what we know, and also graphical relationships, and calculate the perimeter. The reason why we're not calculating area is that we've already done that specific type of problem in my first video. I really wanted to emphasize on that. It's very important. But perimeter is also a little bit more complex as well. And then, of course, we have our congruent triangles, the congruent triangles with the rectangle in between both of them, rectangle or square, depending on the type of parallelogram. That's also what we're going to calculate the relationships. I promised you that in my last video. And then finally, we're going to look into our 2-column proofs, these 2-column proofs, how we're going to break down our reasoning and proofs with postulates and theorems. 2 proofs, 2 very unique proofs, which I'm going to explain to you that we have not covered before. And so reasoning is very important when it comes to parallelograms. And you'll probably see that in videos later on as I get into more complex theorems and correlations between these multiple figures and complex real-life modeling problems. So problem number 1, as I showed you here, our problem number 1 is using diagonals to calculate the area and perimeter of a rhombus. So we're going to calculate the area and perimeter of the rhombus using its diagonals, the perimeter of ABCD as well as the area of ABCD. So what are the values that we're given? So I'm going to give you the given values of these diagonals. So what AC, I'm going to give you this as I would in a textbook. So AC, diagonal AC is going to equal 12 units. And then diagonal BD is going to equal 8 units. All right. So let's take a picture of this rhombus. What is something that you see immediately? One thing that you really see that sticks out to you? Well, something that I notice here is that when you have 2 diagonals intersecting, we know that when diagonals intersect, they bisect each other, meaning they also form a 90-degree angle. So since these 2 diagonals intersect each other under the laws of a parallelogram, and of course a rhombus being a type of parallelogram, we can tell that we're forming 4 different right triangles. And so these 4 right triangles, I'm going to write this here, 4 right congruent triangles. So these 4 right triangles are also going to be congruent amongst each other. All right. So that should be one giveaway here. There's much less of a process that we need to do. Instead of having to calculate the separate area of each and every single one of the 4 triangles created, what we can do is calculate the area of one triangle, such as ABE right here. So we're going to calculate ABE right here, this triangle right here. And if we just calculate the area of this triangle, we can multiply it by 4 to get the total area of the rhombus. So if we're given the values of 12 and 8, we know that our 12 is going to go across, so we know that AC equals 12. That means what can we do here? We know that diagonals bisect each other. So all we need is this base here, AE, and our height, BE. So what we're going to do is we're going to divide each of our diagonals by 2. And we're going to get that our base here is going to be 6 units, and then our height here, BE, is going to be 4 units because we're just dividing it by 2 because we know that diagonals bisect each other. So this triangle right here is developed. So 6 units by 4 units. Now what are we going to do? We're going to multiply 6 units and 4 units together to get our 24 units and then divide that by 2 to get 12 units because that's the area of our triangle. So I'm going to write that out here. So 6 times 4 equals 24. And we know our triangle, you have to divide that by 2. So you get 24 over 2 equals 12 units squared. So 12 units squared. And then what we're going to do is we're going to multiply that by 4. So 12 units squared times 4 is going to equal 48 units squared. So that's the area of our parallelogram. All right, so now let's clear this page up. Now comes the tricky part. Now we have to calculate the area perimeter, which is a little bit more difficult and also easy because it's a rhombus. And what do I mean by that? So likewise, as we had to calculate for this separate triangle, this portion of the area, now we're just calculating for a portion of the perimeter because we know the perimeter is going to be the same. All side lengths are going to be the same on a rhombus. So we can merely calculate the side length of this side AB right here and multiply it by 4 to calculate the entire perimeter. So we know that we have 6 units here and 4 units here. And we know that this is a right triangle as shown here with this right angle in AED. So that means all triangles have right angles. So what can we do here? We can utilize our Pythagorean theorem. Yes, because this is your base right here, and this is your height right here in a right triangle. So that means that this is your hypotenuse. And so we can utilize our theorem in this manner. So we know that our hypotenuse equals c squared. So we're going to plug in our value. So it's a squared plus b squared equals c squared. Plug in our values for a and b. So we have 6. We're going to make 6 our a and our 4 our b. So 6 squared plus 4 squared equals c squared. 6 squared is 36. 4 squared is 16. So 36 plus 16 is going to equal our 52. Yes. So 36 plus 16 is 52. We have our 52 here equals c squared. All right. Now we're going to square root both sides. Square root that. Square root that. We're going to split apart 52 like we would in a radical. So we know that 52 divides into 2. So we have 26 and also divides into 4. So 4 times that would be 13. So we know it's going to be 4. So it's going to be 2 root 13 equals our c value. So that's the value of our given side length right here. And now what we're going to do is we're going to multiply that by 4 times 4. We're going to get 8 root 13 equals perimeter. And that, of course, is units. Always keep that measurement in mind. Very important in geometry. All right, let's move on. Problem number 2. We're going to calculate the perimeter of the parallelogram when it's given on a graph. So let's take a look at this graph. What are some things that come to mind immediately? If we think back to one of my very first videos I made, it was on the distance formula. So we were calculating items on a graph with rotations, all that sweet stuff. And we also looked at the distance formula. So what is the distance formula? We're going to need that, but I'll explain what it is after I show you what the formula is. So our distance equals d, right here, d equals the square root of x1 minus x2 plus y1 minus y2 squared. So that's our distance formula as shown. So what does this actually mean? So the distance formula is when you're calculating the distance between 2 points. This is just a mere review. So when you're calculating the distance between 2 points, you're going to be given one pair of coordinates for one point, which is x1 and y1, and then another pair of coordinates for the other point, which is x2 and y2. So that's what we're merely plugging into this distance formula. So what we're going to do is we're going to focus on this one side right here. Let me just mark this off right here. This is the first side that we're going to focus on. So let's derive those 2 points here. So we see that we have a 1, 2, and we have 2, 4. Those are our 2 points. All we have to do is plug it straight away into our distance formula. So we have d equals square root of r1 minus 2 squared plus 2 minus 4 squared. So let's simplify that. 1 minus 2 is negative 1. Negative 1 squared is 1. So we're going to put that in here. D equals square root of 1 plus, and then 2 minus 4 is negative 2. Negative 2 squared is going to be 4. Add those together. D equals the square root of 5. So now what we've done is we've already calculated what one side length is. So this side length right here is going to be worth root 5. All right. Now, what do we know about parallelograms? What's a very important property? We know that opposite sides are going to be congruent. So we already know that this opposite side here is also going to be root 5 right there. So far, we're gonna keep that as is, and then we'll add it up after we calculate the other side. So now all we need to do is calculate the area of the length of this side right here, and we'll automatically get what this side length is as well. So we're gonna put that into our equation. Let's clean this board up here, and then write down our new points and plug them in. All right. So utilizing our formula right here, we have D equals, or sorry, let's write down our points first. So we have our points here at 2, 4 and 5, 1. So 2, 4 and 5, 1. This is the top side right here, this very top side with the 2 marks on the top. So it's 2, 4 and 5, 1. All right, let's plug that into our equation as well. So D equals the square root of 2 minus 5 squared plus 4 minus 1 squared. And I just want to make sure that you are aware that we can always change the x1 and x2 around as long as we change the other value y1 and y2 around. So we can have y2 minus y1 and x2 minus x1 and y2 minus y1, or x1 minus x2 and y1 minus y2. They have to be in the same exact position. So D equals 2 minus 5 equals negative 3. Negative 3 squared is 9. So we're going to put that in here. It's 9 right here. Plus 4 minus 1 equals 3. 3 squared is 9 as well. So when we add those together, we see that D equals square root of 18. What we can do is we can factor out our 9 here, and we get that it's 3 times root 2. Simplifying that radical. So we can put that in for our side lengths here. So 3 root 2. So now the final step, what's left, is we're basically just going to add those 4 side lengths together. So what do we have here? How can we simplify this very easily in terms of radicals? Because a lot of the times you're going to get radicals, and in geometry, we don't want you guys to round to the nearest hundredth unless specified, but oftentimes it will ask you for exact values, so you can pinpoint what those values exactly are. So we're going to add our root 5 and root 5. So what is root 5 plus root 5? That's our 2 root 5, adding those like terms together. And then 3 root 2 plus 3 root 2, adding those like terms together, we get 6 root 2. And we cannot simplify this down any further, so our answer would be 2 root 5 plus 6 root 2. We're going to leave it as such. All right, let's move on. And of course, keep it in units. All right, let's move on. Problem number 3, we're going to calculate the area of the congruent triangles and rectangle, and that comes when we're going to split our parallelograms. So please refer back to my parallelograms part 2 and part 1 video to really understand what I'm doing here. We're going into these more complex problems. I'm not going to re-explain and waste your time. I'm really trying to get into that, make the most of these minutes that you're watching this video. So this is something that we referred to in our previous video, parallelograms part 2. So what we're doing here is we're going to split this parallelogram up into our 2 congruent right triangles. We're going to form that right triangle here, and those I'm just making altitudes of this parallelogram, and then we have one giant rectangle in the center. So what we're going to do is, if we're given the length of our altitude here, so if we're given that our altitude equals 4 units, we're given that side AB equals 11 units. And then we're given that, I'm going to make this point right here, our F, point F. And let's make this our point B. Okay, so that's our F and point B. And we're given that our point, and we're given that line AF equals 2 units. We have to calculate what the area of ACF, let's make this E here, BED, and FBEC are. So we're calculating what the area of this triangle is, and then this rectangle. All right, let's start off with the triangle here. So we know that since these two are going to be congruent, which I already referred to in my previous video, that's one of the properties of parallelograms. These two right triangles are going to be congruent. So if we calculate the area of one, we can automatically calculate the area of the second one. So let's start off with this value here. We know that our altitude is going to be 4 inches. So we can, 4 units. So we can put our 4 right here. Now the only other value that we need is line AF, the length of AF. So we're given that AB in total equals 11 units, and we're given that AF equals 2 units. So we're already given the values that we need to calculate the area of AFC. So multiply 2 by 4 to get 8, and then divide 8 by 2 to get 4. So that's our area of AFC, and that's also the area of BED. So 4 units squared, 4 units. Let's clear this area. And 4 units squared, 4u squared, just to abbreviate. Now we just need to calculate the area of FBEC. That's our rectangle. So we know that we have our length of 4 right here. So that's our length here. And we need a width FB. So we know that we have 11 units here and 2 units here for AF. We're just going to subtract 11 minus 2. We get 11 minus 2 equals 9. That's the side length, this width right here. So 9 times 4 is going to equal 36. It's 36 units squared. So now what can we do here? We can just add these values up, but what we're really trying to do is we're trying to calculate the separate values, separate areas. So we can write here triangles equal 4 units squared, and that's triangles AFC and BED. And then our rectangle equals 36 units squared. All right, moving on to the final problem. Problem number 4. This is all about proofs, my favorite. I know we all love our proofs. That was sarcasm. So first type of proof that we're going to utilize here is why do diagonals bisect each other? So we know that properties of parallelograms, why exactly would they bisect each other? So the formal proof for this would be the fact that they are perpendicular bisectors, because when they bisect each other, we know that they form 90-degree angles. And when they form those 90-degree angles, we know that they're splitting each other in half directly. So they're perpendicular bisectors. That's the form of proof for this question. And then for the second question, why are opposite intersected angles congruent? So what that's basically saying is if you're given one diagonal and they're intersecting opposite angles as shown on A, B, C, D, why would they be congruent to each other? So what I'm basically saying is why would this angle right here be congruent to this angle here? And why would this angle be congruent to this angle? Well, if you think about it in terms of transversals, meaning AD being one parallel line to BC, which they are actually transversals, which they are actually parallel lines, and this is a transversal, we can tell that this is true by the same side. Sorry. It's true because they are opposite angles. Opposite interior angles. You know that opposite interior angles are always going to be congruent. So A is opposite to angle A1. Let's call this A1 is congruent to angle C1 because they're on opposite interior sides of the given transversal. And then, of course, your A here value, this congruent side here is going to be worth the C. We'll call this A2 right here. And this will be C2, so they're also congruent. And just to recap on perpendicular bisectors, we know that this forms a 90-degree angle on all sides. All these 4 angles have 90-degree angles, therefore they bisect each other at their midpoint, which is located at point E. All right, everyone, so that'll be it for today's video. I hope you guys enjoyed, If you did, please make sure to like and subscribe down below. Leave your comments and thoughts, and also hit that post notification bell so you don't miss out on any of our channel's latest uploads at eCoreAcademy. Feel free to visit our website at www.ecoreacademy.org. Link is in the description as well to check out what kind of interesting content we have there. Full unlocked access to what we as an e-learning platform actually offer to you. So we have all of our videos integrated onto the website. We have progress checks. We have integrated note sheets, quizzes, and worksheets that go along with each and every single one of our videos, with many other perks added. All you have to do is make an account for free to get full unlocked access to everything we offer there. Also, feel free to email us at gmail.com, at eCoreAcademy@gmail.com if you have any questions or if you just want to reach out to us. And finally, check out all of our socials at Facebook, Twitter, and Instagram. Full link is in the description below. See what kind of interesting content we have there and use those mediums to share all of our videos. Once again, everyone, this has been AJ, and I hope you guys enjoyed the video. I'll see you guys in the next one. Peace.